Brian here from quantlabs.net. I'm going to be talking about the new school, I guess you could call it, with all these different topics and courses that I'm introducing to the world for those that want to learn how to do trading and building strategies and trading models and algorithms and that sort of thing. So what I'm about to show you is the specific ones for Matlab. Matlab is pretty well my favorite research tool to really build trading models with algorithms. And it's more than that. It's a fully, it has so much to it. It's like a complete ecosystem with all these different GUIs and graphical user interfaces and different ways to extend a Matlab M Script file to maybe something like C or C++ or Java or C# or even FPGA. I'm going to talk about those as we get to them. This course is really, or set of courses, about 4 or 5 here. They're divided up by toolboxes. These courses are kind of meant for people of all levels. If they're really specifically interested in learning about trading, as well as more of the professional kind of guys that are doing things like advanced quant type of trading strategies. And what I've done is I've consolidated these into 5 courses, as I said before in another video. These are very affordable, I've even got some other ones, as I said, on Simulink and a really different way to do model development. That can all be done visually. I'll talk about that in a minute. But let me just introduce you to the different topics we got. So I said there's about 5 courses. So these are the courses that I'm looking at, and this is now part of an early preview of my school, I guess, for the quantlabs.net. And I'm going to talk in this video specifically what courses and what particular topics are available. These are them. First one's Matlab's Econometrics Toolbox. That's obviously built for specifically trading. There's another one for Financial Toolbox. That's the second course. Another one, now this is where it gets really different, because I've gone through, outside of the Financial Econometrics Toolbox, I've also looked at other toolboxes that could be used on the math side, so they're somewhat advanced. I've gone through all the user guides and gleaned examples that are available through these specific toolboxes that could be used for trading purposes. Specifically, again, as I said, for quant, which is fairly advanced. So I'm gonna combine all these different little uses of all these different toolboxes into separate courses. So there's one course that's dedicated to Matlab toolboxes, one for signal processing, stats, and general math. The other one I've specifically divided up and segregated into is using system identification, wavelet, optimization, and curve fitting. And the very last course is specific to demos, how you could use Simulink, code generate with Simulink into C++, C, and even into FPGA through HDL, hardware description language. And also want you to be aware of, it is highly recommended that you do join the quantlabs.net membership, premium membership, just due to the fact that all my development, a lot of it's going to be done using Matlab. And there's going to be probably another couple of hundred algorithms that I'll be able to have access to use at my disposal and code generate and put them into C. So for those people that really can't afford Matlab, they'll still be code generated from the Matlab programming language M Script, and that will actually be code generated into C or C++. I choose C because it's simpler. You can easily drop that into a trading platform like a TradeLink, obviously that's open source. I'm going to have another video on that for the courses that I have on TradeLink. So again, with the Quant Labs courses and school and whatnot. It's from end to end, from learning how to work with a trading platform all the way to very specific trading algorithms or strategies or models. And again, I'll talk about this Simulink in a little bit, but I'm just making you aware, if you choose this, you should join the premium membership. All the other courses that I'm introducing here by Toolbox, you don't need to join. There's no further obligation. Just specific if you want to learn more about Simulink, because that's something very different that I have not seen elsewhere online or through a school. It seems to be very few people are actually teaching Simulink for trading purposes. So let's get into the specifics of each course. Now again, with the pricing structure on this, is very affordable for what you're about to see for each particular course, and I also have one price for the entire Matlab set of courses that I have, and again, that's very, very affordable. Yeah, I'm going to show you what we're dealing with here. Oh, before I forget, okay, we're going to start off with the Matlab Economic Metrics Toolbox, and this is how each course works. Some courses have one module, and some other courses are divided up into separate modules. So in this case, is Matlab Toolbox course. There's 3 modules, and they're divided up by obviously the signal processing toolbox and the other 2 toolboxes. So there's a module on signal processing, a module for the stats toolbox, and a module for the math toolbox. So that's how the modules come into play, as well as each course and module within the course has its own separate unit. So I'm going to show you how these units are presented. Basically, you just click on one that you have available once you purchase. So in my case, that's not a good example. Just show you this one. Okay, so in this case, in this unit called High, Low, Close, and Bollinger Chart Demo, what I've done is I've introduced all the various functions that are available in this video and in this code sample, code snippet, and give you a link to the specific topic. So here, B-O-L-L-I-G, for Bollinger, obviously. So that's the first thing. And then at the bottom, you'll find the code sample, which is, as I said, in the Matlab M Script, as well as the video itself. So some of the videos are basically walkthroughs, from Quant. Are a complete walkthrough and overview of the accompanying script. Okay, and when you're done with a unit, you just come in at the bottom here, you mark it as completed, and then you get access to the next unit. So let me just show you that. So let me just do a refresh here. So we just worked with the Matlab Financial and here Financial Toolbox. Okay, so as I said, we just finished. We just worked with this unit, and we marked it as completed. Get a little check mark, and then you get access to the next unit. It's just an easier way to manage your progress. Okay. And that's basically how it is. So let me just introduce you to the courses themselves. Okay, so the very first course you could go with is the Matlab Econometrics Toolbox. I can never say that word. So here we got 17 units doing Garch, random walk, Garch parameters, conditional mean response, regression, for tuning and estimating in the markets. Now, just so people understand, if you're coming in from Matlab versus R, I like Matlab for a variety of reasons. I mean, you can go on the blog and YouTube and look them up. But the nice thing about Matlab, and especially the vendor MathWorks, makes all these toolboxes high quality, and you can, without a doubt, even bet $100 million off of these toolboxes, because it's just the quality assurance of these toolboxes are pretty just that high quality versus art. I mean, it could be done from a guy in a garage, and I wouldn't be personally betting a couple $1 million on those type of art packages. But I mean, everybody has their own options and whatnot, and this is one of the things I like about Matlab. And there's a variety of other things I'll talk about when I get there. So we have the Garch parameters and doing unit root testing in a stationary time series. And these are the cool things I like about Matlab, is that each toolbox may have like basically a GUI client, graphical user interface, and you'll see me go on about this in each video, is how you can use and manipulate that tool specific to, just in this case, the financial time series, and be able to do all kinds of crazy stuff. I mean, this one video is probably worth the entire course, because with this type of GUI client, and specifically the financial time series, you can do some very powerful things. And the most powerful thing is you can generate code from whatever you're doing when you do what they call a quote-unquote a study on a particular time series, when you download it or capture it. And again, I have courses on how to do all that and other videos and stuff. So, as I was just bringing that up, it's one of the other big advantages of Matlab. So we go into volatility simulation, and we got some Garch RMax and calculating a max drawdown and expected max drawdown, again, for Matlab. Now we get into the financial toolbox, and let me just, whatever. So we have 8 units here, and depending upon the number of units in each course, I reflect the pricing on the quantity of each course. So I do take into consideration with that, depending upon the length and of each set of modules, the courses, and the videos, and all that stuff. So I do reflect the pricing on that. Okay, so we've got here in the financial toolbox analysis on the high-low close Bollinger. Take a look at mean reverting, maximum likelihood, ordinary least squares, simple regression, Greek analysis for all you option lovers. Look at calculating the Sharpe ratio, risk-adjusted return, ARMA. We also look at regression, fine-tuning, basically how to estimate the markets. Some technical analysis. This is just really the only video you'll get for technical analysis, but it can be done. Obviously, examples use RSI, MACD, Williams R, OBV, time series analysis demo with the, and then again, how to visually work with a financial time series visually within Matlab. Hopefully, between these two courses, you're already starting to see the advantages in terms of productivity with Matlab versus R. If you've seen that video, it's like comparing a little Volkswagen against a Bentley, and just much more you can do with Matlab, and that's what you're really paying for when you use Matlab, is for this productivity and the advancement of the capabilities of these toolboxes and the actual product itself, Matlab. So now we move into the next course on signal processing, stats, and math. When I did the analysis on these are pure math. This is now you're entering into a very quant PhD type of stuff. I mean, this sort of stuff is pretty advanced, and by no means I go on about introducing you to these sort of things. But when you do read the documents and the specific functions, Matlab MathWorks does an amazing job of introducing you to those typical topics. I do also have references through YouTube for various ways to understand stuff. Again, if you're trying to understand the mathy side, you don't need to spend your $50,000 or $100,000 on the PhD or master courses. There's a lot of really good and powerful material out there that you can get for free through Course A, I think, or the iTunes University, and a lot of open source type of courses from the Ivy League type of universities from the States. So there are ways to learn this stuff, but these are specific to show you examples of how to use these type of math principles using Matlab. Okay, so let's go over that. So first we got signal processing. We all know that signal processing in finance is kind of important. So we have here cross correlation from signal processing, something auto-casual, anti-casual, zero-phase filter implementation. These are fairly advanced, so I just kind of quickly just go over them. I don't go into any specifics about them. You just say, hey, they are here, and here's an example of it. That's pretty well what I'm doing in these type of toolboxes. And then we got here all the different units on stats, which again, as we all know in quant, stats is very important as part of the basis and foundation for quant. So we've got maybe fitting copylistic data, this ANOVA, MANOVA, covariance tool. Again, these tools are very powerful. Understanding parametric and estimating empirical CDFs, the D-fit tool, distribution fit tool. Okay, different types of distributions, Markov chains, k-means clustering, portable density function estimating, and then PCA, principal component analysis. Probably overwhelmed right now, but this is the power of MATLAB. This is why a lot of, you gotta remember, bridges, airplanes, rocket ships are all built with MATLAB. And now we're applying it to the world of financial modeling. It can be complex. Now we get into the basic math toolbox, summation, eigenvector, decomposition, factorization with Cholesky, LUDR, fast Fourier, interpolation, ODE with single PDE, and a system of PDEs. And then we get into another course, MATLAB toolbox, toolbox for system identification, wavelet optimization, curve fitting. So with a wavelet, you've got here obviously using Brownian motion, multiple PCA, optimizing. Now, just to give you a tip, a lot of people don't, a lot of real quants don't like to optimize, but I just introduced kind of maybe some particular uses that you can use with it. In this case, calling nonlinear minimization with XStart. And then we get into some really powerful stuff that you probably could do in R, but the way they MathWorks has presented it, these can be very powerful techniques to forecast the markets using both curve fitting and the system identification toolbox. So in the curve fitting, we have demos of splines, analysis plots, and code generation. And again, that's using the tools. As I mentioned before, we can code generate from what you do visually into a code generation into Matlab M Scripting. Very powerful stuff. There's different examples. Again, the curve fitting demo tools using exclusion, selection, smoothing. You can also not just use the visual tools, but you can do it programmatically. Rational fit, surface fit demo, curve fitting using optimization. Now, this is what I would consider my secret weapon. The system identification toolbox is very, 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 very powerful. I haven't seen anything like it out there to learn about quant and forecasting. This is probably the ultimate toolbox to use for that. Combines all these principles and basically what it can be used for. In my case, constructing ID data. I mean, I'll let you figure out what that is. Object time domain, estimating nonlinear ARX models, refining initial RMAX models. These resampling data, custom regressors, identifying time series and predicting a time series, and understanding the continuous time-space model. Ah, boy, there's just so much power to this MATLAB. So now we get into the extra stuff, which is beyond powerful. As you know, simulating generally can be used for rapidly building a model doing it visually, and then from there be able to generate a C or C++ code sample that can easily be deployed into a target trading system. You can also do the same thing for FPGA if you want as well, for the ultimate ultra lowest possible latency out there using FPGA. So this will co-generate into your HDL using either Altera or Xilinx, those specific proprietary languages, HDML I believe it's called, and I can't remember the other one. It'll hit me one day. Verilog, there you go. Alright, so yeah, so I've got some demos here of that using, I shouldn't be in there, the demo of Matlab M cogeneration from the Simulink, and that's all taken care of within Simulink, using a moving average and co-generating it into C++. And the source file is being imported from an Excel spreadsheet, which is a snapshot of real-time data through IQFeed. And that's another example of that. So I have a demo here of how to do that, to generate your Excel file or your CSV file, your comma separated file, using the powerful IQFeed for real-time. And you also use this other tool called Q Collector to be able to properly house it and convert it, and just be able to quickly download your specific stock symbol, be it Forex, equity, future, whatever that you pay for through the IQFeed. So I show a demo of that using a Forex pair, and that can be created using obviously Excel and this Q Collector. Very powerful stuff. Now, I have a video walkthrough or overview of using a typical Matlab Simulink model with Stateflow. Now, Stateflow is another powerful thing within the ecosystem of Simulink, and that enables you to use real-time data flow and event-based and all kinds of crazy stuff. And again, you can use that visually. A whole little introduction on it. If you were, this is why, as I said here, you should join the Quant Lab's membership, premium membership for this sort of stuff, because I have so many other videos and links that show you how to do this stuff within Stateflow. And I've also got some webinars I've done in the past on Stateflow, and then to generate what you use in Simulink, and then be able to co-generate it into C or C++. It doesn't stop there. Once you generate your C or C++, I show examples of how to take your generated code and be able to turn them into DLLs. Now, once you create those DLLs or dynamic link libraries for Windows, you can then take those DLLs and then have them be able to be accessed from TradeLink, your powerful open source trading platform. You can do the same thing with, if you really want to go high end and you can afford it, you can also use something like Deltix as well for that. So that's Matlab. All the courses that are available using Matlab, and again, these are really affordable. And again, I'm sure you probably, maybe by watching this video, you see the enormous power that you get with Matlab, and you can't afford it. I get that. Again, with the Simulink, if you join the quantlabs.net premium membership, what I'll be doing is, as I go through all the models and strategies that I'm presenting here, I'll be co-generating them, hoping into C or C++, so you can then use those code samples and put them into your own trading platforms, again, using something like TradeLink. So you can still use these as an option for C. Now, just so other people know, from my experience, I've worked with Matlab now for just over maybe a year and a bit. And this is one of the other powerful things that I love about Matlab that R really can't do, or Python can't do, or even Java. But the only language or platform that does is Matlab. So let's say you whatever, all these little examples. Let me just show you the example code here. pull this guy up. So, as I said, this is another example unit. Let's say I download this source code, which will be in the Matlab M Script. The powerful thing is with Matlab, let's say if you still want to be able to have that code accessible from a trading platform or some kind of system in .NET, Linux, Unix, it doesn't matter. Matlab has many options to be able to access that Matlab M Script code. The first choice is using toolboxes specifically for development. You could use either any of the Builder NE or the Builder JA toolboxes. The Builder NE for .NET assembly, so you can take your Matlab M Script and run it through a process and then be able to build a .NET assembly from that within the Matlab M Script, and then have a trading platform or whatever in .NET access your .NET assembly, which is obviously going to be a DLL, and then you can access that natively within your C# or whatever .NET language. Another option with Matlab is to use the Builder JA. Does the same it's the same concept, using a Matlab M whatever it is, and being able to virtually build a Java jar file, and then have your other third-party or whatever models or trading platform be able to access that Java jar file. So you can do that through the Builder JA toolbox as well as the Builder NE toolbox. Now, I also didn't mention after 2012A, or somewhere in 2012, MathWorks introduced the capabilities of using either of those toolboxes to be able to access the parallelization of Matlab. So then you can parallelize your code within Matlab, generate either a .NET assembly or a Java jar file, and have your code in .NET or Java access not just the assembly, but able to parallelize it within the Java or jar file or the .NET assembly, and that will expedite your code. That's just one option. Another option, again, is using, talked about it before, is using a Matlab compiler to generate whatever Matlab M Script into C or C++. It's no different than running it through the Simulink coder process. From there, there are some caveats, because you can only really use the Matlab base functions. You can't use any of the toolboxes typically. Like you can't use any of the functions from the financial toolbox or signal processing. Maybe you can, but typically the examples that you would not be able to do this is with the financial toolbox or the economic metrics tool. You can't use any of those functions when you want to code generate using the Matlab compiler toolbox. Now, it doesn't stop there. Matlab also has just recently introduced Matlab production server. No different than this is as of 2013A, where let's say if you want to be able to code generate, to be able to set up Matlab and set up no different than an HTTP server, something like a Tomcat or an Apache or a WebSphere. You can set up your Matlab environment basically, and very easily be able to have your client code, and it talks to pretty well anything. I mean, anything. Java, Python, R. And you can even do this with Hadoop. You can do it with a lot of stuff. And you have the ability to be able to access any of your Matlab M code that resides within this production server. It's a fairly expensive option, and I wouldn't use it for live trading, but it's very powerful for a system or a trending type of model or strategy you want to run for monitoring or some kind of back-end process. But again, I would not use that option for production. The only option on those three that I mentioned, the Builder NE, Builder JA, Matlab compiler, or the production server, and I'm going to use it for specifically for live trading or production, I'd only be using Matlab compiler or the Simulink compiler, just for the sheer fact that you're building native code, and when you're building native code that you can talk directly into your trading platform, let's say TradeLink, you're not using any kind of bridging technology like through the production server or anything elsewhere. It's direct code, and it's code generated into the language that your trading platform will be. So that's pretty well for live trading. And again, I'd only use the Matlab compiler toolbox or the Simulink coder toolbox. That's it for live trading. What else can I tell you about Matlab? There's just so many powerful things that come with Matlab that doesn't have this capability. It has a capability called through a package called RCPP or RMSide, but again, you're using a bridging technology. So let's say with RCPP, you have an R model, and you have a trading platform built in C or C# or C++, and through, let's say, Visual C or through some C language in your platform, you can use the RCPP and basically use that to connect into using a R session, and you're kind of like bridging into R, and you have the ability to pass your C environment and all your objects and pass them into R, have R do something in R specifically, and then return R objects, and the C or C++ objects can talk to each other. Basically, it's very powerful. That's very powerful. The problem with it is when you initiate your R session from your C++, it takes a bit of time. So if you're in a high frequency trading environment, that's not going to cut it, because you're going to need probably, I don't know, 50, 100 milliseconds to establish that R session, which is not the best, not from my point of view at least. And that's why I prefer using a Matlab, just Matlab generally, and then use, as I said, the compiler toolbox or the Simulink coder toolbox to co-generate your C or C++ into your native trading platform. And that's what I'm intending to do, to make it very quick as possible. So, all in all, that's generally everything about Matlab and what I do with Matlab and the courses now I present for Matlab. Very long-winded video. My apologies, but hopefully this will give you an idea with what's being presented here for all this. And yeah, learn Matlab. It's very powerful. Talk to you later.